All right, so we're going to be looking at tangent today. So first of all, let's remember that the tangent of theta is equal to sine theta. Oh, I need to share screen. Thank you. All right, so tangent of theta is equal to sine theta over cosine theta. So what that means to us is that tangent theta is a rational function, right? We have a ratio here, a fraction. And so remember our golden rule, right? Division by 0 is undefined. Remember that? So that means there's going to be some times where tangent is undefined. And what's going to happen on a graph when we have an independent input that's undefined? Something's going to happen, right? So let's take a little side step here, a little detour. If I had f of x is equal to, let's say, x over x plus 3, right? What's my domain? X such that x is all real numbers, but x is not going to equal what? What can x not be?
-3.
Can't be -3. Because if it were, that would be 0. So then on my graph, at -3, at that point -3, what's going to be there at -3? Is the graph going to touch -3?
Asymptote.
An asymptote. Thank you, whoever said that. If we were in class, I would probably throw you a Jolly Rancher or a Tootsie Roll. Yes, an asymptote. Because an asymptote says that the function is never going to touch that x value, right? So if you guys remember this from first semester. All right, so this concept of places where our function is undefined, having asymptotes, that concept is going to come in play with our tangent. All right. So for tangent theta, let's go to our unit circle. So I'm going to put in my ordered pairs, right? This is 1, 0. This is 0, 1. This is -1, 0. This is 0, -1. And then also we're going to be looking at our pi over 4 places. Right? At pi over 4, we're at square root of 2 over 2. Alright, so we're going to do a table of values, thetas, and then tangent of theta. So let me mark again here. This is pi over 2 up here. Here's pi. Here's 3 pi over 2. Should be really, really familiar with those things now. So you'll see why in a minute, but instead of starting with theta at 0, I'm going to start with negative pi over 2. So at negative pi over 2, which is here, right? Cosine is 0, sine is negative 1. So tangent is negative 1 over 0, sine over cosine, so tangent is undefined. And then I'm going to look at negative pi over 4, which is here. So my cosine is positive and my sine is negative, but it's square root over 2 over 2, square root of 2 over 2 and square root of 2 over 2. I'm dividing by itself, right? So it's going to be 1, but cosine is positive, sine is negative, so tangent is going to be negative 1. Alright, now what about at 0? So at 0, sine is 0 and cosine is 1. So tangent is 0 over 1, which is 0. And then I'm going to check out what's happening at pi over 4. So at pi over 4, it's square root of 2 over 2 divided by square root of 2 over 2, which is 1. And then at pi over 2, sine over cosine, 1 over 0, that's undefined. So notice I've got 5 points here, and that's what I'm going to use to graph a period worth of tangent. Come in here. I don't know why I can't draw a straight line even when I have graph paper. Alright, so I'm going to be at pi over 4, and pi over 2, and negative pi over 4, and negative pi over 2. Alright, so at negative pi over 2 and pi over 2, my function is undefined, so I'm going to have a what? An asymptote, right? Let me mark my y-axis, 1 and negative 1. So at negative pi over 4, I'm at negative 1. At 0, I'm at 0. And at pi over 4, I'm at 1. And right now that looks linear, right? But remember, these values, we're going around the unit circle, right? And the tangent is the ratio of the y value divided by the x value. That's not going to be constant, is it? I mean, we could go through and calculate them, but it's not constant. So and we know that our function has to approach these asymptotes. So our tangent function goes like this. Alright, so let's go through and look at all the attributes for tangent. Alright, so the domain for tangent. The domain for tangent is actually the trickiest part. I'm going to actually take a calculator and graph tangent theta for you. You can grab a calculator if you have one. I'm going to make sure that I'm in radians. I am. And I'm going to go to y equals, and I'm going to put in tangent of x. Alright, try and get the glare off of there. Do you see that tangent keeps repeating, right? And so what we've done is we've graphed one period worth of tangent right there, the period that's closest to the y-axis. But then there's another one, and there's another one, and there's another one. So there's lots of asymptotes, right? So if I'm going to say what my domain is, there is a bunch of places that have asymptotes. And so when I write my domain, I have to write all the things that x cannot equal. So keep this in mind, right? It's going to be the same format. So our domain is going to equal the set of x such that x is an element of the real numbers, okay? But x cannot equal so let's look at what it cannot equal. It can't equal pi over 2. Plus, how far away is the next asymptote?
2. No.
What's this distance right here? What's the distance between negative pi over 2 and pi over 2?
2 pi.
Pi?
Pi. 2 pi over 2, which simplifies to pi. So pi over 2 plus pi times n, or n times pi, right? Either way. So every time you're at a multiple of pi over 2, you've got an asymptote. So your domain is very restricted here. You've got lots of things that are undefined. All right, but what about our range? Look at your graph.
Infinity.
Yeah, negative infinity to positive infinity. No restrictions on the range. Alright, so our x-intercept, where do we see an x-intercept? Right there at 0, right? But is that going to be the only x-intercept?
No.
No. We're going to get another one over in the next period. But let's look, right? So from negative pi over 2 to pi over 2, we said that was pi, right? So then if we go over, it's going to be pi over, right? It's just going to shift. So it's going to need to go this much plus that much again, right? So plus pi n. We've got lots of x-intercepts. An infinite amount of x-intercepts, actually.
And then wouldn't the y-intercepts be the same?
And, well, there's only going to be one y-intercept,
Ah.
because you're only going to cross the y-axis at one time. Yeah, really in trig functions, we don't care too much about the y-intercept. But it would be at 0, 0. Alright, so let's talk about where this period begins and ends, which then gives us the period. So we're going to say that this begins at negative pi over 2 and ends at pi over 2. And the reason that we care about the beginning and the ending is that the beginning and the ending defines a period for us, right? So the difference between negative pi over 2 and pi over 2 is a length of pi. Right? So every pi units tangent is going to repeat. Now, the other thing we talked about with sine and cosine was our amplitude. The amplitude, we don't measure amplitude when it comes to tangent. So, amplitude, not applicable. There is no amplitude. None. Max and min, we're going to where? Infinity and negative infinity. Now with our sine and cosine, we said where the max and min occurred, but where are the max and min going to occur? Can you ever actually get to infinity or negative infinity? No. So we can't even say where they occur, right? They're going to approach at pi over 2. Hopefully you can get that concept, but they're never going to equal that. All right, any questions about tangent graph? All right, so then let's look at cotangent. Sorry, I had all these little pieces of paper. I was teaching geometry with a bunch of colored papers, and they're all over my desk. All right, so the cotangent of theta is the reciprocal of tangent, right? So if tangent is sine over cosine, cotangent is the reciprocal, cosine over sine. So again, let's look back at our unit circle here. So cotangent is going to be undefined when the sine is 0. So where is sine 0? At 0 and at pi, right? So we're going to use those as our first 2 points. So I'm going to make a table here. Theta, cotangent of theta, and I'm going to use 0 to pi over 4, to pi over 2, to 3 pi over 4, and to pi. And again, just so you know, the reason I chose these points, right, is because I'm going from undefined around to the next time it gets to be undefined. Because undefined is going to give me those asymptotes, so that's going to tell me where cotangent is. So, cotangent of 0, cosine over sine, 1 over 0 is undefined. Here at pi over 4, cosine and sine are the same value, so when we divide them, that's 1. At pi over 2, if I put cosine over sine, that's 0 over 1, which is 0. Now, 3 pi over 4 is here in the second quadrant. So 3 pi over 4, cosine is negative and sine is positive, so that's going to be negative 1. And then over here at pi, it's cosine over sine, it's negative 1 over 0, which is undefined. Alright, so let's go make our graph. So this time I have an asymptote at 0. So when you go to draw an asymptote on the y-axis, right, suggest you use a different color maybe, and make sure that you make it next to that y-axis, because if you just draw it right on top, you won't really be able to see it, right? And then I'm going to have pi over 4 here, and pi over 2, and 3 pi over 4, and pi. And at pi, I also have an asymptote. On my y-axis, I'm going to label 1 and negative 1. Alright, so at pi over 4, I'm at 1. Pi over 2, I'm at 0. 3 pi over 4, I'm at negative 1. Those 3 points, it looks linear, but it's not, because we're going to come up here and we're going to hug these asymptotes. And we're going to curve through here like this. And when you draw these, they should always have a curve to them. They're never going to be like into a sharp V. I need to do mine a little bit better. Alright, so let's look at these two side by side, right? So we've got our tangent, just going like that, and then your cotangent going that way. No, got my graph upside down. Sorry. Tangent, cotangent. So, attributes, domain. I hope you can see again, this domain is going to be very restricted because it's going to have a ton of asymptotes. So x, such that x is an element of the real numbers, but x cannot equal a bunch of stuff, right? X cannot equal 0 plus pi n. Do you see that every time? Pi, and then you'd add another pi and another pi, or you subtract a pi, there's going to be an asymptote. Range, on the other hand, simple. All real numbers, negative infinity to infinity. This guy begins and ends at 0 and pi, so the period length is pi, just like tangent was. Amplitude is something that we don't measure, really. There's no amplitude. Max infinity, min infinity, negative infinity. Alright, what about our x-intercepts?
Pi over 2 plus pi.
Pi over 2 plus pi n. Right? Pi over 2, and then pi units later, it's going to hit again. Pi units later, it's going to hit again. Alright?